Before we really get to work with scores, we need to learn about lists, because scores are built out of lists. Lists in Nyquist are standard singly linked lists. Nyquist uses dynamic typing, so that means lists can contain any elements, any type of element, any mixture of types. And lists can also contain lists. There's arbitrary nesting, which means you can make an arbitrary binary tree structure by nesting lists. So it's a very versatile data structure. One of the things that made Lisp, the programming language, very popular. And internally, the lists look like this picture at the bottom. This is a list of 3 elements. There are 3 list cells called con cells. Each con cell has 2 links. The first part of the cell links to a value, and the second part links to the remainder of the list. The special value nil means the empty list, and so if you think of list as recursive structures, a list is a con cell that points to a list, then the base case of the recursion is nil, and the last element in the list points to the empty list. Of course, we don't actually construct lists by manipulating pointers directly, although in fact you can, but that's not always the helpful way to do it. We can just write expressions for lists. So in Sal, we can use this curly brace notation, which is the notation for a literal list. So here, this expression means a list of 3 symbols, A, B, and C. Note that this whole expression is a literal. There's no evaluation taking place. A, B, and C are symbols. They are not variables, and they are not evaluated. If you wanted to construct a list from variables, we have another way to construct lists, which is to call the list function and give it an arbitrary number of parameters, which are the list elements. And these parameters are evaluated as expressions in the normal way, and the values of those expressions become the list elements. So here we have some code examples to run through. I'll try to do this quickly. Let's first of all set variables A, B, and C to constants 1, 2, and 3. And now let's try printing some things. If we print this expression, the list ABC, we get, as you would hope, ABC. If we print function call list on the variables A, B, and C, or the expressions A, B, C, these are evaluated to 1, 2, 3, and so we get a list containing 1, 2, 3. Just as if we had applied list to the integers 1, 2, 3 themselves. Now you might ask, hey, is there a way that we can make a list of symbols A, B, and C? Can we block the evaluation? And in fact, there is a special function called quote, which it's special because it does not evaluate parameters in the normal sense. The parameter expression is taken literally without evaluation. That's the purpose of quote. So this is saying I want the symbol A, the symbol B, and the symbol C as elements of a list, and this is what we get. Here's another example where I want to illustrate 2 functions, the list function and the cons function. So cons stands for construct, and but before we get to cons, let's go back and look at list of A, comma, list B. This is going to construct a list with two elements. A gets evaluated to 1. That's the first element. The second element is the list B. So here we have the second element being the list B. Now cons is different. You can think of cons as being a push operation. It pushes something onto the head of the list and returns the new list. It's also equivalent to say that cons constructs a con cell, a list cell, by putting the first element into the head of the list cell and the next item into the tail of the list cell. Either way, the result is that you take the first element and make it be the head of a new list where the second element is the tail of the list. And so when we do cons, we get a different result from doing list. Notice that B here is not a nested list. B is just the tail list of the entire list 1B.